Okay class, today's lesson is on inverses. So we're going to start by looking at inverse of linear functions. So to find the inverse of a function, you switch the x and the y variables. So let's take a look at this example number 1. Pause the video if you need to copy this down. So again, this is the key right here, switching the x and the y variables. So here's your y and your x variable. So to find the inverse, we're going to switch those around. So technically we have the inverse now, but we need to write it as a function. So we're going to solve for y. So solving this equation for y, we start off by undoing, adding, and subtracting first. Remember, we want to isolate the y. So we are undoing GEMDOS. So we start down here with undoing, adding, and subtracting. So we get x minus 4 on the left, 1/5 y on the right. Now the easiest way to take care of a fraction, if you want to cancel a fraction out, is to multiply by the reciprocal. And the reciprocal of 1/5, so we're going to multiply 1/5 by 5/1. And so whatever you do to one side, we do to the other side. So now we have two terms over here, so we have to multiply both of them by 5. So we get 5x. We're distributing the 5 using multiplication. 5's cancel, leaving us with y equals 5x minus 20. Now, so that we can denote means show that this is the inverse, we're going to use a -1 as an exponent. This means inverse. Okay, in example 2, we're given a table of values, and in order to find the inverse of a table, we have to go back to the rule. We have to have this memorized. When finding an inverse, we switch the x and the y variables. So in this case, we're going to switch all the x's with the y's. So to get our inverse table, we're going to switch them around. So our inverse table, switching the x and the y. Notice the sign doesn't change. We're just switching them. And here is our inverse table. So if we wanted to see what they look like, we could graph this one, connect the dots, and then graph this one and connect the dots, and you can see your inverse graphs. Okay, so now we're given a graph, and we want to find the inverse of this function. So not all functions have inverses that are functions. So to determine if the inverse is a function, we have to do what's called a horizontal line test. Horizontal line test. Okay? So if I draw a horizontal line anywhere on this graph, if it only touches in one place, okay? If it only touches in one place, then the inverse is a function. Remember, to determine if it is a function, you do the vertical line test. So obviously this is a function, it only touches it in one place. Well, is the inverse a function? If you draw a horizontal line, yes, it only touches it in one place. So what we want to do here now to get the inverse function is we want to pick some points on the graph. So let's start with this one. That point there is 0, 1, 0, 1. So the inverse point is going to be 1, 0, inverse point. So 1, 0. Okay. This point here is 1, 3. So the inverse point is going to be 3, 1. This point here is 2, 5. So the inverse point is 5, 2. Okay, this point is -1, -1. So the inverse point is also -1, -1. So we're going to switch them around. -2, -3. So inverse point, -3, -2. And so on. So I got enough points here. And there is the graph for our inverse. Now, another interesting relationship between the original function and the inverse is that the axis of symmetry, or the line of symmetry, is going to be line of symmetry will be y equals x. Wait, well, I can't see very well here. Y equals x. So that's there, and there. Line y equals x. We don't draw it as a solid line. It's a line of symmetry, so it's going to go in as a dashed line. So if you take the original function and you reflect it over the line y equals x, it lands on the inverse. They are mirror images of one another across the line y equals x. Now, do all functions have inverses that are functions? Do all functions have inverses that are functions? So I want you to think about that. Can you think of any functions that do not have an inverse that is a function? Can you name one? And can you justify your answer? So think about that. Hope you're having a good weekend. I'll see you guys on Monday.